In the name of Allah, we will briefly discuss a very important topic, which is green hydrogen, and we want to understand its connection with electrical energy. Unfortunately, a very large number of engineers and technicians, especially those working in the field of electricity, do not know what green hydrogen is, what its relation is to electrical energy, and what its global significance is. So, why are most countries in the world racing toward green hydrogen? Why hydrogen in the first place? And what is the meaning of the term green when associated with hydrogen? Is hydrogen really green in color? Are there other colors of hydrogen? We will briefly answer all of these questions in this lecture, but I would like to clarify the most important point in our topic, or rather summarize it in just one sentence, which is, the biggest challenge we face in the field of electricity is the difficulty of storing surplus electrical energy. Of course, everyone knows that the only conventional way to store electrical energy is through batteries. But how much energy can we actually store in batteries? For example, if we have a surplus of about 30,000 megawatts of electrical energy, it is obviously impossible to store such a large amount in batteries. That is why green hydrogen is the only viable solution and the alternative to batteries, as we will learn together. First, hydrogen gas, H2. Before we talk about green hydrogen, I would like to clarify some important points related to hydrogen in general. First, we must understand that hydrogen is the most abundant chemical element in the universe or in nature. It is the most widely available element in the entire universe. Second, it is very rare to find hydrogen in its free form in the universe. Instead, hydrogen is usually found in compound forms, such as in water, H2O, which is hydrogen combined with oxygen. It is also important to note that hydrogen gas is colorless, odorless, and tasteless. I would also like to clarify that hydrogen gas is a diatomic gas, H2, meaning that each molecule of hydrogen consists of two hydrogen atoms. Each hydrogen atom is composed of one proton, positive charge, and one electron, negative charge. We must pay close attention to this particular point, as it will be essential when we explain the relationship between hydrogen and electricity. Let us repeat this again for emphasis. Hydrogen gas consists of two hydrogen atoms, and each hydrogen atom contains one proton, positive, and one electron, negative. The important question is as follows. Why is the world currently focusing specifically on hydrogen gas? We will discuss the issue of color later in this lecture, but for now, why this particular gas? As I mentioned earlier, hydrogen is the most abundant and readily available element in the universe. And as I also mentioned, hydrogen gas is colorless, odorless, and tasteless, but it is a flammable gas that produces a tremendous amount of energy when burned. Hydrogen contains approximately 3 times the energy found in fossil fuels of all types, such as oil, natural gas, and others. Does this mean the world currently needs a new type of fuel? Yes, indeed, the world is currently striving to shift from dependence on fossil fuels, which pollute the air, to a new energy source that is completely free of any air-polluting emissions. It is very important to understand that the world today is extremely concerned and fearful about the depletion of fossil fuels of all types, whether oil, gas, or otherwise. Even if countries currently possess or have large reserves and surpluses of coal, natural gas, or any other type of fuel, the fact remains that after a certain period of time, these resources will eventually be exhausted and depleted. This is the first problem. The second problem is that we must recognize that coal, natural gas, and all types of fossil fuels are the main sources of air pollution and the primary contributors to carbon emissions. Because of this, and due to concerns over air pollution and the depletion of all currently available fuels, whether coal, oil, or natural gas, most countries around the world, including Egypt, are currently racing to develop a new type of fuel that is completely non-polluting and nearly inexhaustible. This is why the current global direction and competition is strongly focused on hydrogen and specifically green hydrogen. It is also very important to know that one of the key advantages of hydrogen is that it contains about 3 times the energy content of natural gas. The second and most important advantage of hydrogen is that when hydrogen is burned, it does not produce any carbon emissions. Instead, it produces water. Just imagine, we can actually obtain pure water as a result of burning hydrogen. But how can we produce or obtain hydrogen gas? As I mentioned earlier, it is very rare to find free hydrogen in the atmosphere or in nature. Hydrogen is almost always found in compound forms, such as water, H2O, which consists of hydrogen and oxygen. Therefore, if we need to obtain hydrogen, it must first be separated from these compounds, whether by thermal methods, chemical methods, or electrical methods. But the question is, from where can we obtain hydrogen gas? Or in other words, what are the sources through which hydrogen gas can be extracted or produced? In order to obtain hydrogen gas, we must understand two very important things. First, what is the source or the raw material that contains hydrogen? Second, what is the type of energy that we will use to separate the hydrogen from the compounds in which it exists, such as water, for example, which is H2O. The most important natural sources from which we can obtain hydrogen are natural gas, coal, and water. But how can we say that we want to move away from fossil fuels, such as natural gas and coal, because they may eventually be depleted and because they cause air pollution, and yet consider them as sources for hydrogen production? Of course, that is not acceptable. Let us not forget that we said the sources are natural gas, coal, and water. That is why all the focus here will be specifically on water. Now, what is the issue with the green color? And does hydrogen really have a specific color? We must understand that the color of hydrogen is simply a symbol that refers to two things: the type of raw material used to produce the hydrogen and the type of energy source used in the process. So does that mean there are other colors of hydrogen besides green? Of course, definitely. But it is important to emphasize that this color is not the color of the gas itself. Rather, the color is a classification that refers to the type of raw material and the type of energy source used. So we would like to know, what are the well-known colors of hydrogen? In order to discuss and understand the different colors of hydrogen gas, we must first identify a set of factors through which hydrogen can be classified by a specific color. So, what are these factors? They are the raw material used, the energy source employed, the method of hydrogen production, and whether or not the process results in any carbon emissions, such as the presence of carbon dioxide gas, CO2, and if the hydrogen gas contains a certain percentage of carbon dioxide, CO2, then what is the concentration or level of that CO2 in the hydrogen? First, black hydrogen. The raw material is coal. The energy source used is thermal energy. The production method is coal gasification, which means heating coal in the presence of oxygen and steam. Of course, the carbon emissions are very high. That means in order to produce 1 kilogram of hydrogen, approximately 19 kilograms of carbon dioxide, CO2, are emitted. Gray hydrogen. The raw material is natural gas. The energy source used is thermal energy. The production method is steam methane reforming, SMR. Naturally, the carbon emissions are very high. That means in order to produce 1 kilogram of hydrogen, approximately 10 kilograms of carbon dioxide, CO2, are emitted. Blue hydrogen. Of course, blue hydrogen can be produced from either coal or natural gas. The energy source used is thermal energy. As for the production method, it is the same as that used for producing gray hydrogen, which is through the steam methane reforming, SMR, process. Naturally, this results in the emission of carbon dioxide, CO2. However, what distinguishes blue hydrogen is that the carbon dioxide, CO2, emissions are captured and treated through a process known as carbon capture and storage, CCS, or carbon capture and utilization, CCU. Through this method, carbon dioxide, CO2, is removed, and as a result, we are able to produce hydrogen while significantly reducing carbon emissions by up to approximately 90%. That is why many people refer to blue hydrogen as clean hydrogen or low-carbon hydrogen. Yellow hydrogen. It is possible to produce or obtain hydrogen from water. The energy source used is electricity generated from nuclear energy. The production method is the electrolysis of water, meaning the separation of hydrogen from oxygen in water. However, we must not forget that the electricity used in this case comes from nuclear power or nuclear power plants, and of course, there are no carbon dioxide, CO2, emissions involved. Green hydrogen. This is the critical and currently most important topic. It is possible to obtain green hydrogen from water, which is excellent. However, the energy source used here is electricity generated from renewable energy sources such as solar and wind power, also excellent. The production method is the electrolysis of water, meaning the separation of hydrogen from oxygen present in water. But we must not forget that the electricity or electrical energy used here comes from renewable energy. And of course, there are no carbon dioxide, CO2, emissions. It is very important to notice that all other types or colors of hydrogen we have discussed rely on some type of fuel, whether coal, natural gas, or thermal energy. Even yellow hydrogen, although it can be obtained from water, still relies on nuclear energy as the source of electricity, which in turn requires nuclear fuel, and that is also a concern. Therefore, we understand from this that any type of fuel may eventually run out, become depleted, or be unavailable, whether it is coal, natural gas, or nuclear fuel. But green hydrogen is completely different because its source is water, and even the electricity used in its production comes from renewable energy such as solar and wind power. As a result, green hydrogen is unique in that all elements involved in its production come from nature, whether water, sun, or wind. This is the reason it is called green. It is a completely safe fuel, an environmentally friendly fuel, a zero-carbon fuel, meaning it contains no carbon at all. For this reason, we will go into more detail about the relationship between green hydrogen and electrical energy and how green hydrogen is considered the fuel of the future. Green hydrogen and the fuel of the future. We spoke a little earlier and mentioned that green hydrogen is produced from water with the presence of an electricity source coming from renewable energy. We also said that the green color is not a description of the actual color of the gas, but rather a symbol of the complete safety in its production, meaning there is no use of fossil fuels such as natural gas, coal, or others, and there are no carbon emissions, which means no carbon dioxide, CO2, is produced. Therefore, green hydrogen is considered an environmentally friendly fuel, but the important question is, how is the process of green hydrogen production carried out? Green hydrogen is produced through a process called electrolysis of water. As we know, water, H2O, consists of hydrogen and oxygen, and by using an electrolyzer, we can carry out the process of breaking down or decomposing water in order to produce hydrogen gas. The electrolyzer is a device that contains a cathode electrode and an anode electrode. As previously mentioned, the electric current or electrical energy used to power the electrolyzer comes from renewable energy sources, whether solar energy or wind energy. As we can see, the electrolyzer operates by splitting water through separating hydrogen from the oxygen present in the water. This process is called the electrolysis of water, where hydrogen gas is generated at the negative cathode electrode, while oxygen gas is released at the positive anode electrode. In this way, we are able to produce hydrogen gas from water, and after that, it can be compressed or stored in cylinders. As for the oxygen gas, it is usually released into the atmosphere. It is very important to understand that the electrolysis of water requires a large amount of electrical energy, and this used to be a challenge in the past. However, today there is a significant surplus of electricity generated from renewable energy sources. And of course, it is not practical to store such large amounts of excess electricity in batteries. Therefore, we were able to use electrical energy derived from renewable sources in the electrolysis process, making it possible to produce large quantities of hydrogen gas which can then be stored. In other words, we have succeeded in storing surplus electricity in the form of hydrogen. But now that we have stored large amounts of hydrogen gas, the question is, can we use this hydrogen to generate electrical energy directly in a similar way to how batteries work? The answer is yes, we can. And we can do so efficiently, even with higher efficiency than batteries. We can indeed use this hydrogen to produce electrical energy directly, and this is what we will now explain. But with regard to my beloved country, Egypt, have we actually started moving forward and making progress in the production of green hydrogen? Certainly, yes, we have already begun operations for the production of green hydrogen. Of course, it is neither appropriate nor acceptable for my beloved country, Egypt, to be delayed any further in addressing the matter of green hydrogen. As we know, green hydrogen is a fuel that exceeds natural gas by 3 times in terms of energy content. Therefore, we have the potential to become a major exporting country of green hydrogen, especially given the distinguished geographical location that God has granted to my beloved Egypt. This is in addition to the abundant water resources and coastal shores, whether on the Red Sea or the Mediterranean Sea, as well as the wind energy and solar energy or sunlight that God has blessed Egypt with so generously. Accordingly, the divine natural resources with which God has blessed Egypt greatly contribute, first and foremost, to the generation of renewable electrical energy, whether from the sun or from the wind. As a result, this enables the production of massive quantities of green hydrogen. As we can see, Egypt has a very significant opportunity due to its access to coastlines on 2 seas, the Red Sea and the Mediterranean Sea, in addition to its substantial capabilities in the field of petroleum. This enables Egypt to store any large quantities of green hydrogen with great ease. That is why we have indeed started to establish multiple projects for the production of green hydrogen in Egypt, specifically in the Ain Sokhna area and the Eastport Side area. Of course, the green hydrogen project will have a capacity of 100 megawatts in the industrial zone of Ain Sokhna. I would also like to clarify that Egypt will produce green hydrogen using electricity generated from renewable energy sources. In addition, blue hydrogen will be produced by storing carbon dioxide gas in depleted natural gas fields. Thus, by the will of God, we will be able to reach a society or an Egyptian state that is completely free from any carbon emissions, achieving a clean environment entirely free from the presence of carbon dioxide gas. Let us talk about the most important point, which is the method of generating electrical energy from green hydrogen. I previously spoke and mentioned that the biggest problem we face in the electricity sector is the large surplus of electrical energy. This means that if we have an excess of electricity and want to store it, of course, the only known method is to use batteries. But we all know what is the capacity and size of the batteries in which we would store electrical energy. In other words, can you imagine if we had a surplus of electricity of, for example, around 30,000 megawatts? How many batteries and of what capacity and size would we need to store all this excess electricity? Obviously, we would need an extremely large volume of batteries, which is entirely illogical, not to mention the extremely high economic cost. Therefore, the only solution for the large surplus of electrical energy was to convert this surplus, which originates from renewable energy, into green hydrogen. In this way, we can store these very large and excess quantities of electrical energy in the form of green hydrogen instead of storing them in an extremely large number and size of batteries. However, now that these large quantities of green hydrogen have been stored and we have a massive stockpile of green hydrogen, let us assume that, for any reason, there is currently a shortage in electrical energy due to some emergency. We urgently need electrical energy to supply very critical loads. The question now is, how can we benefit from this stockpile of green hydrogen in order to generate electrical energy at high capacities sufficient to meet the demands of the electrical grid? Therefore, it becomes clear to us the importance and necessity of the presence of fuel cells, which replace batteries with very high efficiency. Consequently, we must understand what fuel cells are and how we can generate or obtain the required electrical energy through them. Hydrogen fuel cells are devices that directly convert the chemical energy of fuel, specifically the stored green hydrogen, into electrical energy through electrochemical reactions using hydrogen and oxygen. Therefore, fuel cells operate on the principle opposite to that of water electrolysis. As we mentioned earlier, the electrolysis of water involves separating hydrogen from the oxygen present in water. In contrast, a fuel cell works by allowing hydrogen to react with oxygen to produce electric current or electrical energy. From this, we understand that as long as we have stored hydrogen, we are capable of generating electrical energy, and regardless of the quantity of hydrogen, we can indeed produce massive amounts and capacities of electrical energy. This is, of course, the greatest advantage of fuel cells compared to batteries, which require continuous and periodic recharging. Moreover, it should be noted that the chemical substances inside a battery, although used to generate electricity, exist in very limited quantities and are consumed quickly. Once these chemicals are depleted, the battery becomes entirely useless. In contrast, fuel cells never run out or stop working as long as hydrogen is available. For this reason, fuel cells are the most advanced and efficient modern method for generating electrical energy in a completely safe manner and from a clean and entirely safe fuel source. In brief, fuel cells consist of the following components. First, anode. Second, cathode. Third, electrolyte or electrical solution. Fourth, catalyst. But the very important question is, how do fuel cells work? First, we need to understand that the hydrogen gas we will use is compressed. The compressed hydrogen gas enters the fuel cell anode side. Since this hydrogen gas is compressed, it is driven by pressure through the catalyst material. At the anode, the hydrogen goes through a process called oxidation, where it splits into protons and electrons. In simple terms, the hydrogen molecule, H2, breaks apart into two hydrogen ions, written as H plus, and two electrons, written as E minus and E minus, which we can see shown in yellow. The electrons, the two E minus, move outside the cell and travel toward the cathode. These electrons, which constitute an electric current, flow through the external circuit from the anode, powering and operating the electrical load, such as a lamp or an electric motor in a car, and then return to the cathode side of the cell. This is why the design of the anode is important. It contains internally etched channels that allow the hydrogen gas to pass across the surface of the catalyst, and it also conducts the freed electrons and molecules to be used in an external circuit or to power the electrical load. But what happens to the protons, the H plus ions? The two hydrogen ions H plus and H plus move through the electrolyte or the electrical solution toward the cathode. It's also important to note that the electrolyte is a polymer membrane that only allows positively charged ions, H plus, to pass through, while it blocks the electrons, E minus. That's why it's called a proton exchange membrane, or PEM. As a result, the protons, H plus and H plus, move through the electrolyte to the cathode, and the electrons, E minus and E minus, travel on the outside of the cell to the cathode. At the cathode, they all come together with oxygen, which gets reduced to form water. This also explains the design of the cathode, which has internally etched channels that distribute the oxygen across the surface of the catalyst, allowing it to combine with the hydrogen ions to form water. Thus, we have made significant progress and achieved tremendous success in the field of generating and storing surplus electrical energy. Consequently, all this excess renewable electrical energy has been converted into green hydrogen. In this way, and through the use of fuel cells, we can at any time produce or obtain unlimited electrical energy as long as there is a stored supply of green hydrogen. Of course, we must not forget that, by the grace of God, Egypt has a very large surplus of renewable electrical energy, whether from wind power stations such as the wind power station in Gabal el Zayt, the wind power station in Zafarana, or the solar power stations at the Benban site. Does this mean that we produce and store green hydrogen solely to generate electrical energy when needed? Certainly not. But is it possible to benefit from green hydrogen in other applications besides electricity generation? Therefore, and in summary, we can mention the most important uses of green hydrogen as follows. Firstly, one of the most important uses of green hydrogen is that it shares the same applications as natural gas. Thus, we can use green hydrogen instead of natural gas for cooking and heating in households. We can also use green hydrogen as a substitute for natural gas in vehicles. Additionally, it can be used in fuel cell-powered vehicles. Moreover, green hydrogen can be utilized in various industries, including the production of ammonia and fertilizers. Thank you for your attention. See you in the next lecture.